Getting towards the end of the chapter, there's one sort of new thing we need to talk about, which is dealing with hinges. So look out for being told that something is smoothly hinged. So hinges are questions where we're dealing again with rods. Okay, so the same sort of skills, you know, the up, the down, the left, the right, the clockwise, the anti-clockwise. But we need to know what a hinge is really and how to handle it. So the short answer is when you have a hinge, the questions normally look something like this. So you have, say, a vertical wall, and then you'll be given maybe like some kind of bar or something like that. And then this thing, so imagine it like a hatch that folds down from the wall. Somewhere here it will be attached with a string. So I'll put T for tension. Okay. And why does it have that string? Well, it has that string because the object has some weight to it. So this is kind of the situation. You know, no floor, usually no peg. So this is like the third situation I would call the hinge situation. So where's the hinge? Well, the hinge is at the wall. Okay. When you're like pulling down on this bit here, you can imagine that some work would be being done over here. Okay. We can also go back to our idea where this tension's going to the left, so it seems like something should have to go to the right as well. But it's more than that. We're not going to just do like a normal reaction. Because it says a hinge, what we're going to do is we're going to say that there's a horizontal and a vertical component. Okay, so you can call these things, say, like you can call this X and Y or whatever letters you like. But there's four main things going on in this question. So there's usually like tension for a string. There's the weight of at least the object itself. Sometimes there might be like something sat on here as well, which creates another one. But it's this kind of situation that is possible for them to ask you about. Okay, if you've got a really old version of the textbook, it doesn't actually appear, but this very much is in the specification for the course. In fact, I'll put those ones back on there, but then let's leave our diagram like that. So let's go back to reading it through. So it's a light inextensible string, so no surprises there. AC equals 3. So why are they giving us distances? Well, they're giving us distances because we're going to have moments again. You have to read the letters very carefully because they can look slightly differently, but look, they're saying, you know, A is here, B is here, C is where it's attached, D is above. So that's how you would piece together the diagram. And I'm going to just kind of show you the neat version. And what we're looking for here is we're looking for two things. We're looking for the tension of the string first, and then we're going to come back to this one sort of here, part B, in a moment. So this is what your diagram would look like. It would look something like this. Okay. And how do we handle the questions? Well, you probably guessed already. We just start with whatever's easiest, really, out of this stuff, and we work our way through them. So let's do all of the forces up first. So we've got V going up. T also goes up to the left. So it's possible, isn't it, to resolve it into like a left and a right. Yeah. I'm going to put 40 here, and I'm going to use my diagram like this, just because if I draw my triangle inside like that, there's just too much going on. Okay. So I'm going to draw 40 there, and I'm going to say that if that's T in a right angle triangle, that's sine. So I'm going to say this is T sine 40. So there's T sine 40 going up, and then there'll also be T cos 40. Okay, so resolving in a similar sort of way to what we've done before. If we just color code it a little bit, you can see that it's sort of ready now. So we've got V, we've got T sine 40, we've got 6G is the up and down in the question. We've got pushing away from the wall, that part of the hinge, and then we've got going there. So that's the first part of what we're doing. So up was V. They called it V, so I'll use V plus T sine 40 equals 6g. And then what have I got for the other bit? Left equals right. I've got t cos 40 equals h. Okay, and it is v and h. It's not mu r or anything like that. It's a hinge. So we're going to go with them being separate letters, not connected. Now that doesn't look that useful really. So it might be that moments is more useful. So where would we take the moments from? Taking the moments from here works really well because v and h are there, and when you take moments somewhere, you don't have to consider the forces at that point. So we're going to take moments at A also. There's a force here, 6g, that is 2 meters away, and it's already perpendicular. So there's a 12g force down here, and that's going clockwise, isn't it? Anti-clockwise, so what's stopping it going to the floor if it's in equilibrium? Well, it must be this tension, and conveniently I've already resolved that on that diagram. So can you see that that tension, now that I've resolved it, it's useful also for the moments. It's 2 meters, 1 meter, it's 3 meters away. So it's 3 meters away, and it's t sine 40. So that is the moments calculation. So the moments calculation is what is easiest in this. So if I divide by 3, I get 4g. So 4g over sine 40 should be equal to t. And if you do that, t is 61.0 newtons is what I've got written down. Okay. So that's your part A, to find the tension in the string. So similar themes as we've done so far, resolving, vertical, horizontal, but also moments involved. What we're going to do next, the magnitude and direction of the force exerted on the rod. So what's being done to the rod by the wall? Well, really it's talking about the hinge. That's what that's doing. It's a little bit confusing, but it's really saying what's going on at V and H. It wants the magnitude, so that's like Pythagoras, the size of the forces, and direction, well, that's because there's 2 of them, so you can make a triangle of them together. So if you sub in the t values here, you should be able to get the v and the h value, and I'm going to just save a bit of time and work those out for you. So the vertical is going to be 19.6 and the horizontal is going to be 46.7. Okay, so that's what these do. And you draw yourself a force triangle, so that's 46.7, that's 19.6, okay, and then the magnitude is just using a bit of Pythagoras here, so I'll do 19.6 squared plus 46.7 squared, and then I'll square root that, and I get 50 we were doing, was it 1 decimal place? So I'll just go with that again. So 50.6 newtons is the magnitude, and the direction, well, that means that I should work this one out here. So if I did inverse tan of the opposite over the adjacent, okay, bear with me, I don't have these numbers just yet. So 19.6 over 46.7 in degrees, so that's 22.7, no, I'll round that, so 22.8 degrees to the horizontal. Okay, so that's sort of how you answer hinge questions. So hopefully if your foundations are good from earlier on, it's not too much extra. The key thing is you've got to assume that there's 2 things going on at the wall, which is also where you take moments, and they're not connected. Give them different letters like V and H or X and Y. The other bits and pieces hopefully shouldn't be too bad.